Hello, in this video we're going to look at synchronizing motion with Unreal Engine and a custom server. So what we're going to be doing is synchronizing the motion of a character using WebSockets against the server. So I've actually done this using HTTP protocol before. It can be found over here. But in this post we're going to be using WebSockets. So WebSockets will have lower latency, so it's a bit more efficient. So it's a little bit better than just using direct HTTP commands. So yeah, that's what we're going to be looking at here. And as usual, all the steps in order to accomplish this can be found in this blog post. So it literally goes step by step on what you need to do in order to accomplish this. And one of the things or prerequisites is to basically install this Blueprint WebSockets plugin inside your Unreal Engine, as that's what we're going to be using for handling communication. So it's actually even easier than using C++ code, which is great. So that was pretty nice. So perhaps the first thing that we'll do is go and have a look at the demo. So what we've got is our character selection screen. So here we've got a character. I'll click login. And as before, this character will get put into the world, right? So the key here is that you can see all of these updates right now. So I think every 100 or 50 milliseconds, I'm sending an update to the server about the whereabouts of this character and what it's doing. So you can see if I start moving, this data keeps getting updated. So you can see the XYZ coordinates are updating. I also have the pitch, roll, yaw, as well as the velocities as well. So this basically keeps the character synchronized with the server. The cool thing is that, for example, if I go over to the bridge here and then I log out or close the game, if I'm going to restart the game, I'm going to pop back into the same spot because the server knows where that character's at, right? Like it knows what's going on with that character. So that's what we're going to be implementing here. And in the next post, we're also going to start synchronizing other players on this map, right? So at the moment we're synchronizing this character on the map. And in the next post, we're also going to be obtaining information about the nearby characters and also rendering them on the map as well, right? So that's what we're going to be looking at building here. So let's get started. So we'll begin with a character. So what we have is a player character. So this is the same one that we've looked at in the previous episode. And what we're going to want to do is create a new graph for synchronizing motion. So perhaps one of the first things that we'll do is create a new custom event. And just call it something like create WebSocket, right? So what we'll want to do is link that inside your constructor. So we'll go into construction script. So this is what we've built in the previous episode. It's not a prerequisite, so don't worry if you don't have that at this stage. Obviously, it's definitely good to have it because that's what positions your character in the last position, right? When you start the game. So it's definitely useful, but it's not a prerequisite, right? If you want to just synchronize the motion, it's possible to just get started here, right? So just link that new event inside the constructor for your character. So now let's go back to synchronize motion. And what do we do? So first of all, we create the URL to which we're going to connect to, right? So before we create the WebSocket itself, we want to create the URL. So how do I get the URL? So obviously you'll have some documentation for your server. In my case, it's this one over here. So you can see there's localhost v1 player motion. So this is like the base URL, I'll call it. And then I've got two variables. One of them is the map and the other one is the character name. So these two are variables. Okay, so that's what we're going to be building here. And the way we do it is just using some append string functions, right? So basically, this is my base URL that I just referred to earlier. So localhost port 8081, v1 player motion, and then I get myself the map. And I get that from the player motion, which I've extracted from the game instance settings. So again, you can make the static if you want right now, particularly if you just have the one map, you can just put that as a static variable. And then also the character name. So again, I got that from the game instance, which is, just basically our global variables. So I get myself the account character, which contains the character name. So there's my player motion /map/character name. Okay, so now that I've got myself this URL, I can go ahead and create my WebSocket. So if you don't see this available, that's because the plugin hasn't been enabled. So in order to enable it, just click Edit, Plugins, and then find your plugin over here. So Blueprint WebSockets, that's the one we're using. the reason why it's a little bit better than the stomp over WebSockets is on that one, you had to predefine the URL, and I couldn't put any variables in there. I'm not sure if that's by design or like what's happened there, but that was the issue with this blueprint. This one allows me to define it over a parameter. So as I'm creating the WebSocket, I can define my URL, and in my case, that URL can change. So that's why I went with this blueprint. So it works pretty nicely. Anyway, so now that you've got this plugin enabled, if you type create WebSocket, you'll see this become available, and that's what you want to use. So we feed in our server URL that we've just created, and then we promote the output to a variable, so WebSocket client, and then we're going to need to do some binding, right? So to be honest, I think this might be optional, right? But these get called. So you can see here, for example, bind on connect. So these bind events will get called whenever certain actions happen, right? So it's like trigger things. So bind event on WebSocket connected. So that means that once I hit this connect and it actually connected successfully, I'm going to get callback into this event, right? All I'm going to do in this case is print a string saying WebSocket connected. So this is useful for debugging. And I'm also going to set a Boolean to true for WebSocket connected. So this will be useful if I'm, like, for example, if I get disconnected, I don't want to be trying to send messages, right? There's no point because I'm disconnected. So that's why I've set this Boolean. It's not fully finished, by the way. You'll see that shortly because I've got bind connect, bind on send, but I didn't bind on disconnect yet, so I'll do that later. It's kind of an optional thing for now. So bind on send, again, when I am sending a message, I'm going to get a call back into this function, and all it's going to do is print string the message, right? So that's where you saw me populating the messages over here. I'm sending messages to my server, and I'm just basically updating the messages that I'm sending on the screen. So again, it's for debugging purposes. So that's why I say it's not really required. Okay, so once you've bound these events, you can go ahead and connect. So we provide the WebSocket client, and then we set the update timer. So what that actually does is basically periodically start sending updates to the server. So let's have a look. This is a set timer by event function. So this is just a standard Unreal Engine function. And basically I can say every 0.05 seconds in a looping motion, call this event, right? I'm also just basically refactoring that send command over here, just so I can then move it around to wherever I like without it being connected by this line, right? So this could have been connected directly here, basically, right? Okay, cool. So what do I do? Whenever I'm trying to send every 50 milliseconds, I first want to make sure that my WebSocket is connected, right? So if I'm not connected, don't send anything. Then I'm going to be updating the player motion, which basically is the structure that you can see over here. And how does it do it? Well, basically I get, this is inside the character class, right? So the parent here is the character, which means I can get self, which is the character pawn, basically, right? So with that self reference, I can get myself the actor location, actor rotation, and actor velocity. So these are the three pieces of information that I want in order to populate the motion structure, right? So I put a player motion structure over here, and I'm going to be constantly updating it with a player's motion every 50 milliseconds, basically, right? So that's what this one does. It basically gets the actor location, breaks the vector into the three numbers, truncates them because these are doubles and these are integers, which maybe I'll change in the near future. I'm not sure if I need that accuracy, right? I think like I probably don't, but if I do, maybe I'll change that. But anyway, so I populate the motion structure, get actor rotation. This one was slightly, I mean, I'll show you now. And all of these steps are documented, by the way, right? So, but by default, when you get actor rotation, you're going to see this rotator object. So what I did was split the pin to get myself the three numbers, right? So, and that way I can feed them into the structure. Otherwise, it might be a bit confusing what to do. And then I get the velocity as well. So once I get all of those, I populate the motion structure, and I'm done here. So I can go back to synchronize motion. So we were over here. So update player motion. So once we've got ourselves the motion structure, we want to convert it to JSON, right? So pretty much all API requests, any web requests, they're very often in a JSON format. So we're not actually going to be sending this JSON object because this command, this WebSocket implementation accepts string, but we convert it to JSON because there's a really nice function of encoding JSON to a single string, and we can just feed that string in, right? So again, this is just to simplify it. Mind you, it's not going to look simple, but in reality, it's still simpler than doing some stuff in C++. Now, to be honest, C++ is not very good with these serializers. You know, Java, Python, Ruby, they're very good at serializing data. They just do it by default. I didn't see this a library or a good library in C++. If you know one, do share it because it looks messy in C++ as well. So basically, I used make.json from VA REST. So VA REST is another plugin that's available. I've used it quite a few times for HTTP protocols here. So I was able to just make JSON for the motion and then convert that to a string, right? So basically, I get myself the motion structure. You can see my input here is motion. My output is VA REST JSON object. And basically, for each one of the fields here, I'm going to basically set them up in the JSON format. So set map to map, set X to X, set Y to Y, etc. Right? It's just simply reflecting this structure. So once I complete it, so there it is, literally going through each field by field, and then I go ahead and return it. So once I returned it over here, I'm simply going to encode it into a string and send a message using the WebSocket client, right? And again, what I'm replicating is basically this. Now, in reality, at the moment, all I care about are the three coordinates, X, Y, Z, and the map, right? I'm going to be using the rest of them later as well, but just at this point, I just need those four variables. So in the next episode, probably going to be using a bit more. But like I say, this is what we're trying to replicate. So there's the URL, there's the encoded string, and once you connect and send, it's going to be sending that data. So in fact, I'll show you what we get, right? So there's my character 2, and I'm going to send a motion with this data, and it's going to say, okay, I post this data, and it's actually going to respond with some information as well. So what it responds with is other nearby characters. So we're not going to be consuming this data at this stage. That's going to be done in the next post. But we're going to be getting some information about other things that are around us, right, to draw them on the map. Okay, and that's pretty much it, right? So what we can see here is that well, it's all encapsulated in this functionality here. So we create the WebSocket. So we needed to create the WebSocket URL. This is cool because, you know, if we're opening a new map, that means this WebSocket layer will get destroyed and a new one will get created. And when a new one gets created, it's going to be populated with a correct map in the URL, right? So that's taken care of just by having it connected to the constructor. Then we recreate the WebSocket, which you'll need to do whenever you change the URL here. We promote that to the variable, we bind the connect, we bind the onSend, we actually connect, and we set the timer up so that we periodically start updating the server with a location. So some of the other things that we're going to be wanting to do is, for example, bind on connection closed, right? So we're going to be disabling the WebSocket connected variable. We're also going to be binding on message received. So basically, we're going to start processing the data received from the server and then actually doing some stuff with it, right? So that's what we're going to be looking at in the next episode. But for now, you know, this is just an incremental update to the journey. So yeah, I hope all of that makes sense. Any questions, do let me know. Otherwise, best of luck and see you next time.